The function g is a function in the form g of x equals a times b to the x, where a is greater than 0, positive, and b is in between 0 and 1, exponential decay. The function g is also given by g of x equals f of x minus 5. All right. So which of the following statements is true? So they want to talk about proportional over equal length input value intervals. First of all, g of x is a standard exponential function, right? Since a is positive and b is in between 0 and 1, it is exponential decay, and then when graphed, it's going to look like that. Anything in this form is going to be proportional, because I can make a table and I can show you that as my y values increase, you're multiplying by the same number every single time. So g of x is proportional, is prop. Now, g of x also happens to be f of x minus 5. I don't know what f of x looks like, except if I add 5 to both sides, f of x is now g of x plus 5. Now, I don't know what these numbers are. Okay, I'm going to make something up. Since I know it's decay, I'm just going to pretend that you're 20, you're 10, and you're 5, because I'm dividing by 2 or multiplying by a half every single time. However, if I all of a sudden say f of x is this guy, and I'm adding 5 to it, that would make you 25, that would make you 15, and that would make you 10. And there's no number that I can multiply to 25. I mean, multiplying 25 to, what would that be? 3/5 would get me 15. But multiplying 15 by 3/5 does not give me 10, which means f of x is not proportional. And that's because I'm adding that 5 there to an exponential function. So the output values of both are proportional? Nope. The output values of f only is not g are proportional? Nope. The output values of g only, not f, are proportional? Yep. And neither? Nope. Tricky problem, very, very, very strange, but that's how you do it. The answer is C.